I, Dr. Mohan L. Verma, welcome you in this course on fundamentals of engineering physics. And today's topic that is we are going to discuss is electromagnetic waves and the polarization phenomena. So, in this lecture we are going to learn, that is given here is an outline, that is we will think why light is so special, and the second, in which form light actually propagates, and then the Huygens model of light, actually the wave theory of light, and how this idea of electromagnetic waves came, because this topic is related to electromagnetic waves. Then the question is obviously that is how this idea of electromagnetic wave came, and then the concept of particles and waves, and next we will discuss on what is electromagnetic wave actually, and also the method of generation of this electromagnetic wave. And the question is obviously how electromagnetic wave is generated. This is a big question. And then the various properties, we will list out these properties and discuss of electromagnetic waves. And we have a broad band of spectrum of this electromagnetic wave. So, we will discuss about this spectrum at a glance in short, and then we will discuss about learn about that different application of this electromagnetic waves in its spectrum. So, objectives of this talk, that is to impart knowledge on the concept of electromagnetic wave, to impart knowledge on generation of electromagnetic waves, to introduce various properties of electromagnetic waves, to give comparative analysis of electromagnetic waves in terms of wavelength and frequency, because these are the characteristic of a wave, and to discuss about the different applications of electromagnetic waves. And after attending this lecture, what you will get, that is this topic actually enables you to understand the basic concepts of electromagnetic wave in its spectrum, the broad spectrum, and you will be able to apply this electromagnetic waves, its application in different advanced studies, and also you can apply frequency wavelength relation to solve some concerns mathematical problems. So, now let us start first with the first question, that why light is so special. So, light plays crucial role in the understanding the structure and properties of various things, from atom to universe, from that microscopic level to that huge levels up to that universe, and without light even our eyes cannot see objects. So, without light nothing we can imagine about. Now, the question is this this light, about this light, what is actually light? This actually puzzles made many physicists, scientists sleepless until the middle of 19th century. Up to different models have given to explain these properties, and this is only because of that abundant properties. We have a big list of properties of this light. It travels in straight line, it has different colors, it has reflection, refraction, polarization, total internal reflection, interference, diffraction, scattering type phenomena. So, light can disperse, and we have the concept of that lenses, mirrors, depending on its properties. So, and also apart from all these, that general properties which we have learnt in our school level physics, we have a list of some distinguished properties, special properties like black body radiation, Compton effect, advanced level properties like photoelectric effect, specificity of solid. So, these are that properties. So, we have a big list to give the properties of this light. That is why this light is special until now. So, that the studies on that light, it actually begins in 16th 17th century, and after 200 and 300 years we are still studying that properties of light in its a different form. So, that is why light is special. Now, the question is in which form light propagates. So, from which this light is actually made up of. So, the first effort that was given by Sir Isaac Newton, obviously this is that a great scientist known for his gravitational theory and other things. So, great scientist, he have first effort to explain, to interpret the behavior of light. And he proposed that the propagation of light is actually caused by a rectilinear linear motion of light particles, and he has mentioned these light particles as the light corpuscles. So, light has a different size of particles, and these particles travels in with a finite speed, which is further known as that speed of light, and its value is calculated as 3 × 10⁸ meter per second in vacuum, and that the interaction with external environment and all these actually obeys that Newtonian physics, that physics which we have studied up to our school levels. So, this is that particle of light, and he also explained that each colors. So, we have different colors of light, and each color is encoded by the light the particle size of this corpuscle, light corpuscle. So, if we have that blue color and then the red color, then the particle size of that blue color, violet color, that will be different from that light color. And this theory of light, this propagation and the composition explains the basics of optics, including optics within lenses and through pinholes, reflection of light, refraction of light. So, the basic phenomena which we have studied in our school level physics, that the properties of lens, mirrors and other things, these can be explained on the basis of this theory given by Isaac Newton. But this first effort was actually very good opening, but failed. Why? Because the concept of massless corpuscle, this cannot be accepted, because if it is particle, so it will have this mass and momentum, and if you are saying that light is a particle and it is massless, then this concept cannot be accepted. As well as that maximum properties Newton tried to explain, but he was only able to explain that reflection, refraction type of basic phenomena concerned with light. So, we have that interference, diffraction and other high level properties of light that cannot be explained on the basis of this theory given by Newton. Now, the next theory come in picture, and that was because of this Huygens, and this is known as Huygens model of light. So, this Huygens in 1678 has given one theory to explain that behavior of light, and he proposed that the nature of light can be better understood by observing the motion of water surfaces, and this light travels actually in form of longitudinal wave, and the different colors of light is because of that a different wavelength. And he extended the understanding of light as a wave by proposing the concept of primary wave front and secondary wavelets. So, he tried to explain the different phenomena, and he have given the new concepts of that wave fronts. He have classified there are 3 types of wave fronts, and there are the concept of secondary wavelets to explain that interference type phenomena. But the thing was, he has stated that light has a longitudinal property, where that the particle of that medium with that wave, it is oscillating in the direction of propagation of light, that is longitudinal wave. So, this was wrong, because light contains a polarization type effect also. That if it has polarization, means it is not a longitudinal wave, because we know about that sound waves. Sound wave is a longitudinal wave, and it does not contain that polarization type properties. So, fractionally in 1817 he has corrected that statement given by Huygens, that light is not a longitudinal wave, but it actually propagates in form of that transverse wave. So, that transverse wave means the oscillation of that particle, it is perpendicular to the direction of propagation of light. And this model explained maximum properties of light, but failed. Why? Because light was considered as a mechanical wave, and a mechanical wave needs medium to propagate, but the proposed medium by Huygens, that was ether, it cannot be, it could not be proved anymore by a chemist or physicist, because this was a fictitious medium, and its property was special properties, and it could not be explained. And also some properties like that photoelectric effect, Compton effect, and the special properties, it cannot be could not be explained by using this theory. Then the problem was problem of medium to propagate for the mechanical wave, that was overcome by this James Clerk Maxwell, a great scientist of the modern physics. So, he enlightened that the concept of light from his theoretical prediction that light is an electromagnetic wave, and we know that electromagnetic wave never need a medium to propagate. So, that medium, that ether, the problem of that ether medium, that was overcome by this Maxwell's theory. And later it was also confirmed that visible light is just only the small portion of electromagnetic spectrum. So, we are very happy that we have that light, and we generally think about that light has that visible range starting from 4000 angstrom to 7800 angstrom, starting from that blue color to red color. No, it is just the small part of that electromagnetic spectrum, and actually this spectrum ranges from gamma rays to radio waves. And in our everyday experience, we know there is nothing mysterious about the concept of particles and waves. From our school days, we are from our birth we are observing that particles, and we are observing that waves, and these are not new thing for us. And in our school levels we have studied the different properties of particles and waves, although the mechanism of these particles and optics of waves, these are very independent disciplines. These are different from each other traditionally, and we have different experiment to distinguish, to measure different properties of particles and the optics. So, we have set of properties of that particles and optics. These are different to each other. We know this, we consider electron as a particle because that electrons possess charges and mass, but in forthcoming lecture we will see that this electron will have that wave nature also when that electron will be in motion. And also we also regard that electromagnetic wave as a wave with suitable circumstances that exhibit different properties like diffraction, interference, polarization. But we shall also see that under other circumstances that electromagnetic waves behaves as through they consist of stream of particles. So, what is actually this electromagnetic wave is? This electromagnetic wave, this is actually the coupled electric and magnetic oscillation that moves with the speed of light and exhibit typical wave behavior. So, this is just the coupled electric field and magnetic oscillation. These are associated with each other and moving together with the speed of light in a specific direction and showing that wave like behavior. And we know that from our school level physics about the behavior of charged particles. So, if the charged particle is at rest, it generally generates that electric field and also that electric potential, and we have that Coulomb type relation to calculate that electric field, electric potential for electrostatic thing. And it also generate electric that current when it moves with a constant velocity. So, we know that current, it is the rate of change of charged particles, and if there is some current flowing in a particular wire, then the neighboring of that wire we can calculate that magnetic field strength, and that magnetic field strength, it is mathematically given by that Ampere's law as well as that Barton-Severt law. These are that school level physics we have studied. But what is about that accelerated charge? Because these two properties, these are because these are of either that rest charge or that charge moving with constant velocity. So, that the behavior of this accelerated charge particle, this was observed by the British physicist James Clerk Maxwell in 1864, and he has made the remarkable suggestion that this accelerated electric charge generated linked electric and magnetic disturbance that can travel definitely through space. And if the charge oscillates periodically, if it is a periodic motion, it is moving with a constant frequency. So, if the charge oscillates periodically and the disturbance or wave whose electric and magnetic components are perpendicular to each other and to the direction of propagation also as shown in this diagram. So, here if that electric field is oscillating along x axis, and that magnetic field that will oscillate along y axis. So, that x axis and y axis, this is mutually perpendicular, and that the direction of propagation that will be z axis. So, that the oscillation of electric field, oscillation of magnetic field and that direction of propagation, these are mutually perpendicular. So, how this idea of electromagnetic wave came? So, for that we have to observe that earlier work of that English scientist Michelson Faraday. We have that Faraday's law. So, with this Maxwell knew that this changing magnetic field can induce a current in a wire loop, and this is known as the Faraday's law of induction. And so this Faraday's law of induction, we know that EMF, it is proportional to rate of change of the magnetic flux, magnetic flux density, and there we have concept of that inductance type things are there. So, that if that magnetic field, the change in magnetic flux, it can generate EMF. And then the Maxwell proposed just the converse of this. If that the change in magnetic flux can generate electric field, then also that the charging electric field can have the generated magnetic field associated with it. So, that reverse concept that was proposed by this Maxwell's. So, this is actually the symmetric type behavior, and that is speciality of this Maxwell is this. He has a set of different equations by creating such type of symmetric behavior of different properties, either in electrical properties as well as thermodynamical properties. We have a set of that equations. So, if Maxwell was right, this electromagnetic wave must occurs in which constantly varying electric and magnetic fields are coupled together by both electromagnetic induced, and this converse mechanism is proposed. And Maxwell was able to show that it's at that speed c, it is equivalent to 1 upon root of mu naught by epsilon naught, and it is calculated by Maxwell's to give that the velocity of this electromagnetic wave, which is actually the equivalent to that velocity of speed of light in the free space or in vacuum. And here that mu naught, epsilon naught, these are just the permeability and permittivity term related to electric and magnetic field. And one thing here I would like to mention that this epsilon naught, mu naught individually has no physical meaning. These are just the constant associated with that electrostatics or magnetostatics. So, that we have 1 upon 4 pi epsilon naught, this is one constant, 9 into 10 to the power 9 minus 9 meter, the Newton per meter square, and that, and also that mu naught by 4 pi, that is in Weber. So, these are just the constant proportionally constant used by Coulomb. But when we this two coefficient, that epsilon naught, mu naught, it is associated, and 1 upon root of this mu naught, epsilon naught, this gives that spatial property of the light, that is the speed of light, and it is concerned with that speed of that electromagnetic wave. And if we have that mu or epsilon naught, then obviously that is the relative permittivity, relative permeability of that material. So, this is material dependent, that has that physical meaning, that is other things. So, okay. So, this electromagnetic waves travels with a speed which is equal to the speed of light in vacuum or the free space. These are that properties here we are listing out. And second, in a medium with permittivity epsilon and permeability mu, the speed of electromagnetic waves nu, this is less than in free space or vacuum. So, in the medium we know that the also for the light also we know that in vacuum and in air we can think that the speed of light is c, but when we go to that medium, then its velocity decreases, and that velocity, this is concerned with its refractive index, mu is equivalent to c by v. Okay. So, that is electromagnetic waves are not deflected by electric field and magnetic field. Remember this, although this electromagnetic waves consists that oscillating electric field or magnetic field in mutually perpendicular direction, but it is not deflected by electric field or magnetic field. These electromagnetic waves can exhibit interference, diffraction, polarization phenomena, means this has a wave behavior. And like other waves, these electromagnetic waves also carry energy, linear momentum and angular momentum. So, these are that different properties a simple wave has. So, also this electromagnetic waves contain these properties. Electromagnetic waves are produced by any accelerated charge. So, this is the form of energy, and this electromagnetic wave do not require any medium to propagate. So, electromagnetic wave is a non-mechanical wave, and also electromagnetic waves are transverse in nature. The oscillating electric field vector, oscillating magnetic field vector, and propagation vectors are mutually perpendicular to each other. So, these are that different specific properties of electromagnetic waves. So, now let us come to that spectrum. this is very famous spectrum which is known as electromagnetic wave spectrum. So, this electromagnetic wave spectrum is the entire range of electromagnetic waves in the order of increasing frequency and decreasing wavelength. So, obviously, this frequency and wavelength, these are inversely related. So, that frequency increases and that wavelength will decrease. So, this is that schematic diagram of that electromagnetic wave spectrum. So, let us begin with the first part, that is its ultraviolet light. So, this ultraviolet light, this is the part of that electromagnetic EMF spectrum, and it is discovered by Ritter in 1801, and its wavelength range from 400 nanometers to 10 nanometers, and the frequency and energy is high enough with ultraviolet rays to penetrate living cells and cause them damage. So, generally precaution was suggested that avoid this ultraviolet light to directly dropped on the skin. Although we cannot see UV light, it is invisible. Bees, bats, butterflies, some small rodents that can and birds can see these ultraviolet lights. UV on our skin produces vitamin D in our bodies. This is also benefit of this. This is the benefit of this UV, but not that enormous amount of that ultraviolet light. So, that is the specific time span is required here. Too much UV can lead to sunburn and skin cancer. This is the danger thing, and UV rays are easily blocked by clothing and used for sterilization because they kills bacteria. So, these are some applications and properties are listed out for this ultraviolet light. Next is the radio waves, and it is discovered by Marconi in 1895, and this wavelength of this radio waves, it ranges from 1000 second of meters or thousands of meters to 0.001 meter, and it have the longest wavelength and the lowest frequency, and it is used in radars, cooking food, satellite transmission. So, radio waves are very important for that transmission of signals through satellites. So, that mobile phones and other things are running because of these radio waves. Infrared wave, it is discovered by Herschel in 1800, and it has shorter wavelength, obviously higher frequency from, and the wavelength range is from 001 meter to 700 nanometers, and it has high frequency and used for finding people in the dark, and that it is also used in our TV remote control devices. So, in maximum remote control devices we use this IR waves, infrared waves. Visible light, so it is first studied by obviously Newton in 1666, and its wavelength ranges from 700 nanometer, that red light, to 30 nanometers violet light, and with the frequency higher than that IR waves, and these are the waves in the EMF spectrum that human can see, and visible light waves are very small part of that EMF spectrum. Its wavelength range is very small, and its application is very high because it enable us to see the object. X-rays, it is discovered by Röntgen in 1895, and this wavelength range is from 10 nanometer to 0.001 nanometer. So, that this wavelength range, it is in the sequence, but we have shown in that spectrum, that wavelength spectrum, and these rays have enough energy to penetrate deep into the tissues and causes damage to cell, and these are stopped by dense materials such as bones, and used to look at the solid structures such as bones and bridges, for cracks and for treatment of cancers. So, these X-rays, and one special thing here I would like to mention, these X-rays are only one single invention which is adopted experimentally within the 3 years of its invention. It was actually discovered by Röntgen in 1896, and first time this X-ray was used in 1899 to check that the fracture of bones. So, this is passing to that medical science by physicists, that X-rays, and also for the material characterization, to observe that structure of that material, this X-ray diffraction phenomena, it is used abundantly for experimentalists. Now, gamma rays, it is discovered by Becquerel and Curie in 1896, and this carry the most energy and have the shortest wavelength in less than 1/1,000,000th of the meter, so 10⁻⁻12, and these gamma rays have enough energy to go through most materials easily. You would need to 3 to 4 feet thick. This is very dangerous. Gamma rays are released by nuclear reactor in nuclear power plant, by nuclear bomb, and by naturally occurs elements on earth, and sometimes it is used to the treatment of cancer. So, one benefit is here, but there are other properties which shows this gamma rays are so dangerous. And let me first summarize whatever we have observed in the different properties of these electromagnetic waves and other things. So, we have started from this particle nature of light given by Newton, where Newton failed because of not showing not explaining different properties of that wave, and also that massless concept of that particle of light. So, this was a big drawback, and it was tried to overcome by Huygens with his wave theory, where we have that the light, it is propagating in terms of that transverse wave, which is actually corrected by shown by that Fresnel, and maximum theories maximum properties of light that was explained by this theory, that wave theory given by Huygens, by using that the concept of this wavelets, concept of wave fronts, secondary wavelets, this type of things, and that different colors are because of that different wavelength. But one drawback with this theory, that was the concept of the existence of ether as a medium to propagate, because it was thought that it is the mechanical wave. And also we have some list of properties of that wave, that was that photoelectric effect, Compton effect, black body radiation, specific heat of light. These are some special properties of that radiation which couldn't be explained by this Huygens theory. One problem that was overcome by this the next theory given by Maxwell, that was the need of that medium to propagate. So, he has considered that this light is not a mechanical wave, this is actually that electromagnetic wave. Actually, this electromagnetic wave does not need a medium to propagate, and then we discussed about the different properties of waves. So, this the generation method, although this is experimentally proved by Hertz in 1888, but before that the Maxwell has given the theory related to this electromagnetic waves, and this is just the concept reversed to given by the theory given by Faraday, where we have that Faraday's law of induction, that Faraday has stated that if we have there is a change in the magnetic flux, then it can generate EMF. So, this Maxwell thought that if there is some change in magnetic flux, it is generating electric field, then if there is a change in electric flux or electric field, then it should generate that magnetic field too. There is, because nature is symmetric type behavior should be there. So, he has associated this oscillating electric field and oscillating magnetic field, coupled these two, and give the concept of this electromagnetic theory, and that he has also calculated this the velocity of this electromagnetic wave, c is equivalent to 1 upon root of mu naught epsilon naught, and that this is further proved by Hertz, because of this experiment we have that one unit of frequency of Hertz. So, this Hertz has proved experimentally in 1888 that these electromagnetic waves or radio waves exist. Then we think about that a broad spectrum of this electromagnetic wave, and in this spectrum this visible light is very small part, and we have that X-rays, gamma rays, ultraviolet rays, and different properties, broad properties of this electromagnetic wave we have. Now, the concluding part, in the end of this we will discuss about that polarization. Because of this this particular phenomena, that one statement was given by that Fresnel, because initially it was taken thought is that this light is longitudinal wave, but longitudinal wave does not keep polarization type behavior. So, polarization is only because of this transverse wave. So, first of all, what is this actually the polarization is? this polarization, it is the property applying to transverse wave that specified the geometrical orientation of oscillation. So, we have this oscillation of this electric field, we have that oscillation of that magnetic field, although these are mutually perpendicular direction, but this is that the symmetric type behavior. So, this is that symmetric behavior. So, in general this polarization is defined as if this symmetric oscillation, if it is confined in a specific direction. So, this oscillation is like this, like that. So, in all direction that oscillation is there, two dimensional. If it is oscillating in a specific direction, means that property, that symmetric type this wave, it is now converting into asymmetric, then this phenomena is known as polarization. And we have that some tools like calcites and prism and calcite crystal type things, where there is one axial type behavior, and ordinary light has that oscillation in a different direction, especially this electromagnetic wave also, that oscillation, one oscillation is along y axis and another oscillation is along x axis, light is propagating along z axis. So, that oscillation are in the transverse direction. When we use that calcite type system, then this oscillation are confined to that specific direction, then this is known as polarization. And this polarization is actually divided into two parts, that either linearly or circular type polarization. And this polarized sunglasses, we have the concept of this polarized sunglasses, we are using sunglass. So, what the function of this sunglass is actually filters that light. How it filters? Because it just works as a polarizer. So, we have that sunlight coming to our sunglass, and there are that different oscillation in different direction. So, that sunglass actually just allows some that light which is oscillating in one specific direction, means that unpolarized light, it is converted into polarized light, where that oscillation in a specific direction. So, its intensity reduces because of that the reduction of that thing. So, that polarized sunglass can filter the polarization from specularly reflected sunlight, and sunlight is scattered by aerosols in the atmosphere because of that polarization scattering phenomena, and that radio stations in the polarization, especially that radio stations normally use this vertical polarization, and TV stations are used horizontal polarization. So, that vertical polarization means it's that oscillation is considering only vertical direction, and in this horizontal polarization means that all the other oscillations are stopped, and that only that horizontal oscillations are being allowed in this that station, that especially that in TV stations. So, these are that polarization, and this is one of the special property of that electromagnetic waves. Okay, so I think thank you all, and happy learning.